is we're going to be building a really simple on-chain, a really simple on-chain kind of like points program. And so the idea over here is assume you launch some token, let's say meme, and you set up a Uniswap pool for each slash meme, right? The goal is to incentivize people to buy meme and also to add liquidity to the ETH meme pool. So as a result, we're going to sort of create that incentive through like a points program style thing, right? So we're gonna we're gonna issue points every time someone buys meme for ETH in the pool, and also we're gonna issue points every time someone adds liquidity to the pool. And disclaimer, note slash disclaimer, this is not a production ready design, and closer towards the end, once we've sort of built it out and developed an understanding of it, closer towards the end, we'll talk later about improvements slash things to keep in mind if you want to build on top of this and make it a bit more quote unquote secure or mainnet ready, basically. So this is going to be intentionally very simple, and therefore we're going to cut some corners. And the way points themselves are going to work, the way points themselves are going to work is they'll simply be an ERC20 token of their own. So like imagine like a point token, and we'll we'll simply be minting point tokens to users um, when those two actions take place, right? And also um, arbitrary rules. As the benevolent dictator of this project, I am going to randomly just assign a rule of like how do we decide how many points to give out, right? There's a question like how many points to give out um, for the actions. So just as the dictator over here, I'm just going to randomly just say that for every swap, 20% of the amount of ETH um, in the swap will be minted as point tokens. So for example, if you spend 1 ETH purchasing meme, you will get 0.2 point tokens. And also for every add liquidity action, we'll just say like 100% of the amount of ETH you add as liquidity will be minted as points to you. So if you add 1 ETH plus some amount of meme, you get 1 point token for that. This is arbitrary. You can have this different, you can make this different, you can make it significantly more complicated. You can have like a curve instead of it being like linear like this, you can have like a polynomial curve over here or something like that to make it more fancy. But for today, we're going to keep things simple and just have this like really basic rules, right? So with that kind of out of the way, let's see, terminal font. Okay, let me know this is readable for everybody. Okay, so that kind of out of the way. The first thing you want to do when you want to start building hooks is we're going to install one dependency that is going to be the Uniswap slash v4 periphery. Now, previously I described, Uniswap's code base, V4's code base is kind of split into two parts. There's V4 core and V4 periphery. Core is where like all the mathematics and all the equations and all the calculations logic lives, and periphery is kind of where like some of the base contracts and helper stuff lives for people who are looking to build on top of Uniswap. So as hook developers, everything we need can be found pretty much inside of V4 periphery. So install that dependency. And while we're at it, we also need to configure Foundry for a couple of things. So Uniswap v4 only works on Solidity versions 0.8.25 or above. I'm just going to do 0.8.26, but basically anything greater than equal to 0.8.25 can work. And then you must be on the EVM version Cancun, this is where this is the hard fork where EIP 1153 was merged, aka transient storage. Uniswap v4 makes heavy use of transient storage. You need to tell Foundry to use the Solidity version and the CVM version, otherwise it won't be able to compile it. And then that's pretty much about it. You can also enable like optimizers and VIR and stuff if you want, but these two are critical. You need to do this anytime you're developing hooks. And this version you can go to like an even newer version, I think now, but Cancun is the minimum EVM version you need to use for building hooks. And lastly, we'll just set up our remappings. Um, cool. So we'll get rid of the what do you call it? The default generated files from Foundry, encounter.sol and stuff, and we'll just create our own file, call it pointshook.sol. Okay. Now, the way sort of hooks work, or like the way building hooks works, is I'm going to go into lib and let's take a look at what v4 periphery actually gives you, right? So in v4 periphery, if you go to source, base, and hooks, there's this contract, the base hook.sol. And this is an abstract contract. It does exactly what it sounds like, right? It's like the base implementation for building a hook on top. So generally, most of the time when you're building a hook, you want to kind of just extend from the base hook contract, and it has like a couple of niceties built into it that you don't need to worry about at that point. So let's say I'm just going to copy paste this stuff, and we want to import base hook. This comes from v4 periphery slash source slash base slash hooks slash base hook dot sol. And your contract we're going to do is, let's say, contract points hook is base hook, and this is like super basic boilerplate, right? But then we also need to have our constructor, because the base hook contract expects the address of the v4 pool manager in its constructor. So we need to take that in the actual constructor over here. It's a type I pool manager. I'm going to import that. It's the interface for the pool manager contract. Import that, and we'll just pass it along. Like it'll just go down towards the pass it along to the base hook contract. Right. The other thing we want to do right now, and specific to our use case, is since our hook is going to be minting these point tokens, right? What we're also going to do is we're going to make our contract an ERC20, and oops, sorry. We're going to make our contract an ERC20, so you can import ERC20 from Soulmate. v4 periphery has a further dependency on Soulmate, so we don't need to install it separately, but import ERC20 and also extend ERC20, and then we'll also initialize ERC20. We'll call it points with a symbol of point, and also 18 decimal places. Cool. So far, so good, right? Simple bootstrap boilerplate code. Anybody have any questions so far before we jump into like actual hook related stuff? Okay. I'm gonna take that to mean no questions so far. Okay, cool. So then let's take a look at base hook again and see what is it that we need to build. So every hook contract, whenever you create one, the first thing you need to do is you need to implement this function called get hook permissions. This one is just a view function, right? Actually, pure function, and this is mostly used for just like off-chain stuff. I'll show you what that means. But basically, this get hook permissions function returns this hooks.permission struct, where hooks is the v4 library. And this struct, what it looks like, it's basically all the different hook functions that can possibly exist, right? So like before initialize, after initialize, whatever. And basically, you're just returning a struct from here that is saying like which of these functions are you implementing? So the ones you do implement, you return true. The ones you don't implement, you return false, right? This is not validated on chain. This is purely for like off chain reasons. So, if you're building a front end or something, you have like the address of a certain hook contract, you can kind of call this and check out like what functions this hook is claiming to have implemented. Um, it's a simpler alternative for off-chain data parsing compared to, you know, doing the thing with the hook's contract address. So in our case, let's actually talk about then in our case, what hook functions do we need for what we are trying to do over here, right? So we said we're going to issue points every time someone buys our token for ETH, and we're going to issue points every time someone adds liquidity to the pool, right? So this immediately kind of gives us the idea of like, okay, for the first case, you want to use either before swap or after swap. And then for the second case, you want to use either before add liquidity or after add liquidity, right? So then how do we decide? How do we decide if you want a before hook or an after hook? So let's talk about that. Let me close that. Increase font size again a little bit. Okay, so which hook function to use? Um, cool. So give people points when they purchase meme. Our options are before swap or after swap. So sometimes, certain types of hooks, it doesn't really matter which one you do. Sometimes it's possible that you can use either and it doesn't really affect your thing. But in our case, it actually does make a difference, right? It's not there's actually a reason where you cannot use before swap for what we're trying to do. You must use after swap. So, and like we have the similar option for like give people points when adding liquidity, and we'll have like again similar like either we use before add liquidity or we use after add liquidity. So let's think about why we have to make this decision of using the after hook in our case. So let's say there's this person Alice, and Alice said she wants to purchase meme for 1 ETH, right? Like she's willing to spend 1 ETH, and she doesn't know exactly how much meme she's going to get for that. So at a very high level, the way Uniswap v4 works is obviously there's the swap function that Alice is going to call, and at a super high level, it's going to internally do before swap call, and then what we call the core swap logic, and then it's going to do the after swap call, right? This is super high level structure of the swap function, right? The thing is, when Alice said she wants to purchase meme for 1 ETH, um, question to the audience, answer this in chat. Are we guaranteed that when the swap actually happens, she will actually be spending 1 ETH? Right? Like, is there a case where 1 ETH doesn't get spent? Any guesses in chat? Okay. So, as it turns out, there are actually two cases. Uh, okay. We can use fixed output or fixed input. Okay, great point. So then consider that. Um, there's two types of swaps Alice could have been doing, right? She could have been doing fixed input ETH for meme, or she could have been doing fixed output meme for ETH. Um, let's go case by case, right? Let's go case by case. So in case number one, fixed input ETH for meme, is there a possibility that um, by the time the swap actually happens, whatever fixed input ETH she said, like let's say she said 1 ETH fixed input, are we 100% guaranteed that 1 ETH will be used for the swap? Yes, no, okay. So the answer is actually no. Um, we are not guaranteed that her full fixed input amount will actually be used. What is possible is it's possible to use less than her fixed input amount because if we hit her slippage limit or if pool runs out of liquidity, you know, or like something happens like the price shifts or whatever, like if things like that happen, the transaction will be kind of like the swap will only fill partially, right? Like we're not guaranteed that the swap will fill 100%. It might only fill partially. So so at this point is until the swap actually happens, which is core swap logic, right? Until core swap logic actually has a chance to run, we don't exactly know how much ETH Alice is actually spending in the swap because it's possible it's only a partial swap. And then for the second case, the fixed output meme for ETH, this one, you know, by definition, this one we don't know exactly how much ETH will be spent in the swap until after the swap logic has run, after core swap logic, right? So these two things, if you notice these two things, what you realize is based on our rules, because we set our rules that we're going to issue points based on how much ETH is being spent. Um, but we don't know how much ETH is being spent until after core swap logic has been run. So for that reason, we cannot use before swap or before add liquidity for what we're trying to do. We must use after swap and after add liquidity because once the core swap logic has been run, then we can actually know for sure, how much ETH was spent, and then as an implication of that, calculate exactly how much points to give to Alice, right? So with that in mind, let's go back to our code and in our get hook permissions function, um, I'm going to copy paste this, but basically it's the struct, all the 14 functions, and we've just marked after add liquidity and after swap to be true. Everything else is false, right? So we're only going to be implementing those two functions. Cool. The next thing we're going to do, let's create stubs for these two hook functions. We're going to come back to writing the full code for this, but let's create stubs and we'll reference base hook in the process. So let's take a look at after swap. What does after swap take in? Um, so after swap, the first argument. Well, let me write down all the arguments first, and then we'll go over one by one on what that is. So, actually, I might as well just copy this and then go over one by one on what each of the arguments is doing. Okay, so let me also actually do this for after add liquidity and kind of review them basically. Okay, so after swap, the first argument takes us an address. It's the sender address. And we have the pool key. The pool key is basically, like if you think of like all the pools in existence in UniSwap v4 as like a key value thing, like it's a mapping, right? It's like key value. So pool key is kind of like everything you need to uniquely identify a pool. It basically just contains, the token pair addresses, the fee, the tick spacing, and the hook contract attached. So it just identifies which pool is being interacted with. Then we have the swap parameters, the swap params given by Alice for what she wants to do. We have this thing called the balance delta, and we'll talk about this a little bit more shortly. And then finally, we have this argument hook data. We'll talk about this in a second as well. For after add liquidity, it's basically the same thing. You have the sender address, pool key, the modify liquidity parameters, balance delta, a second balance delta, and then hook data. So there's a couple of things to note over here. A couple of common pitfalls plus balance delta. Let's understand this. Oops. Okay. Okay. So, number one pitfall. This is the most common mistake new hook developers make. Um, while most hook functions have an address sender as the first argument, whose address is this actually? So there's a question open to chat. Um, what would you expect this address to be? Like imagine like it's Alice. Alice is, doing the swap ETH to meme. Uh, well, whose address do you expect you'll find in this first argument? And I kind of already gave you a hint that, it's not the obvious answer over here. So um, the address that initiated the transaction, what do you mean by that? So would that be Alice? Alice is the end user who's doing the swap. Do you expect to find Alice's address here? Okay. Any other guesses? The pool address. Uh, interesting. I think you're coming from like a Uniswap V2, V3 background where each pool had its own contract address. In V4, pools don't have their own contract address. Everything is part of just the single pool manager contract. So we don't really have the concept of like pool addresses anymore. Any other guesses? Okay. So you mentioned Alice. It's a fairly decent guess. I think intuitively that is what would make sense, but it's actually not Alice's address. And the reason for that is it's actually not really possible to find Alice's address at all. Because what happens is um, the way Uniswap works, and this is true for V2, V3, and V4, right? Like end users cannot call the pool contracts directly. In V4's case, that would be the pool manager. In V2, V3 case, that would be the pool smart contracts, like the individual pool smart contracts. And users cannot call those contracts directly. They must be called via a swap router of some sort. So, for example, like Uniswap's universal router or like the MetaMask router, you know, or whatever, like 1 inch aggregation router, whatever. There's a bunch of these routers out there. And the flow generally looks like Alice does router.swap, and then router does like pool manager.swap in our case. So the sender address in hook functions is not the end user. It's actually the router that we're talking about. This is a common issue. And it's also impossible to find Alice's address because then you might say, oh, we can't use message.sender for Alice's address. Maybe we can use tx.origin. And that's also not true because what can happen is a couple of things, like especially with like account abstraction these days and paymasters and whatnot. Um, the person who's paying for the transaction on chain might not necessarily be the user who's actually doing the transaction. So transaction.origin is also not a good reference to find this out. And also, Alice might not be initiating the swap herself. It might be like a yield generation protocol or something like that that automatically is doing this on behalf of Alice, in which case as well, you won't be able to find Alice's address. And this point will come in important to us because in our hook, then how do we know which address to mint point tokens to? If we don't know Alice's address, how do we know to give her points? So this is a question I want you to keep in your mind as we progress, and we'll get back to this. The other thing I want to talk about before we write the rest of the code is this balance delta parameter. Um, so with balance delta, the way to think about it is balance delta is kind of a struct. It's not really a struct, but it is kind of a struct. And you can think of it like the struct that has two values, a int128 amount 0 and another int128 amount 1. So what these means is amount 0 refers to the amount of token 0 in the pool that is being that needs to be transferred, and amount 1 is the same thing, but for token 1 in the pool, right? And what do I mean by transferred? Note that both these values are ints, they're not uints, which means they can be negative. And this leads us to like this sort of convention that Uniswap has introduced. There's a convention that when we talk about tokens being transferred, um, Uniswap treats positive and negative values a specific way. Um, all values are represented from the perspective of the end user. So a positive value implies um, money plus plus, basically, for the end user, i.e., tokens need to go from Uniswap to user. And then a negative value implies basically money minus minus for the end user, i.e., uh, tokens go from user to Uniswap. So, for example, in an ETH meme pool, where ETH equals token 0, meme equals token 1, if Alice swaps ETH to meme, the balance delta struct for her will look something like amount 0 will be some negative value, something like, let's say, like -1 ETH, and then amount 1 will be some positive value, let's say, like 5,000 meme tokens. Um, and just looking at like this balance delta struct alone, basically you can tell, what the user spent and what the user got back. Negative value means this is money coming out of the user's wallet, and positive value means this is money going into the user's wallet. And this is true all across Uniswap, like whether you're adding liquidity, whether you're removing liquidity, whatever sort of actions you're taking, if you ever come across a variable that is supposed to represent amount of tokens being transferred, it will always follow this positive negative convention, where a positive value would mean user is getting that token, and negative value would mean user is paying that token to Uniswap. Um, okay. So like in the case of a swap, right, it's going to be one negative value, one positive value. Similarly, if Alice was instead adding liquidity, let's say she was adding 1 ETH plus 5,000 meme as liquidity to the pool, in that case, her balance delta will actually be like both will be negative numbers because they're both coming out of her wallet. So they will both be negative numbers in the balance delta. And it is basically through this balance delta that we will find out how much ETH was actually spent in the swap or how much ETH was actually added as liquidity. Because all we need to do is just look at the amount 0 of the balance delta and we'll know how much ETH was being spent. Okay, enough yapping. We'll write some code and let's do it. Oh, sorry. One last question. We briefly raised this question of like, how do we know which address to mint points to? And, we don't have a way built in where we can just find uh, Alice's address directly. So what we're going to do is we're going to rely on the hook data parameter. And somebody mentioned this in chat already. Yeah, we can embed that in hook data. So what is hook data? Hook data is basically, sorry, hold on. Sorry, I'm getting a call. Okay. Hook data is basically a param that, well, hook data is basically arbitrary info. Like user can pass along arbitrary information in hook data that will simply be passed down to the hook contract, and the hook contract can do whatever it wants with it. So it's like you can pass in literally anything. So in our case, what we're going to do is we're going to ask the end user when they're making a swap to include an ETH address inside hook data. And basically, whatever address is in there is the address who's going to get point tokens minted to them. Now, this is kind of a maybe not the best example of hook data, but like you can also think of hook data. Better example to understand it. It's kind of like if you think about like a hook that does KYC, right? Maybe it's like an enterprise grade trading solution or something where you want only certain whitelisted people are able to trade in the pool, or like, some sort of KYC. And perhaps you have like a ZK proof or something to prove that a given user is part of a some sort of whitelist. What you can do is you can pass that ZK proof into hook data, and the hook contract can allow that trade to occur. And if no ZK proof in hook data, the hook contract uh, can just revert the swap transaction and not let the swap happen. Right? So hook data can be arbitrary information that the hook might need to control the behavior of user actions, right? In our case, we're going to use it to figure out who to mint point tokens to. Cool. So with that out of the way, we're going to start off by writing a little helper function, call it assign points, that will take in the hook data and we'll take in, let's say, we've calculated at this point how many points to give out, let's say. So this is an internal function that we'll use in both of our hooks. And what we'll do is, so if there is no hook data, if user didn't supply hook data or whatever, then no points will be issued because we don't know who to issue them to. So we'll just do if hook data.length equals 0, just return. Oops. Then we'll try to extract an address from hook data if it is not empty. So we'll go address user equals abi.decode hook data and try to decode it into an address type. If address is 0 address, it wasn't like properly formed, or if it's just like 0 data in there, then also you just return. We don't care about that. Otherwise we just call mint, right? And this mint function exists because of the fact that we are inside an ERC20 contract, right? So we just mint this user whatever number of points we want to mint through this internal function. And then we can go into, let's start off with after add liquidity. What we can do is we want to do a couple of sanity checks over here. The first sanity check we want to do is we want to make sure this swap is happening in a pool that is ETH/token, right? Like at least one of the tokens in the pool must be ETH. That is the core concept. And by convention, if the native token of a chain, i.e. ETH, is part of a pool in UniSwap v4, it will always be the token 0. It is impossible for a pool to exist on Uniswap v4 where one of the tokens is the native token, ETH, or like on Polygon, like Matic, right? And have it be token 1. It will always be token 0. So to check that, we're in a pool where one of the tokens is the native token, we can just check the token 0 value. We can do that code ourselves, but there's some helper libraries that we get from Uniswap that make life slightly easy for stuff like this. It's called a currency library that we can use on the currency data type. And let me add the import for it. So if you remember, we have this pool key, and this pool key is what identifies the pool we're operating in. If you look at the pool key, we have the two tokens represented as this currency data type. It's basically just a wrapper around like a contract address with some helper functions built into it. So to check that, ETH is one of the tokens in our case, all we really need to do is we just need to check that if pool key dot currency 0, and we have this helper function, is address 0. So basically, if key dot currency 0 is address 0 is false, like if this is not true, that means we are not in a pool where ETH is one of the tokens. And in this case, we're just going to return the default value from this hook, which would be the function selector of the hook itself, and then the balance delta. We just need to return like after add liquidity has two return values. This can be different for each hook function, but this one has two return values, the function selector and the balance delta. So we just returned those default values, no changes made. Important note here, do not revert the transaction here. Note we are not reverting the transaction. We are only returning from this function. The reason is if you revert this, then the whole transaction will fail, right? The user won't be able to add liquidity. But that's not what you want. What you want is like somebody set up a pool where they accidentally added your hook contract, perhaps, right? Um, you don't want that pool to basically just become non-functional because of it. Just let people add liquidity like normal. You just don't need to mint them points or anything. So you just return out of here. You don't revert. There are cases where reverting does make sense, like the KYC hook, for example, where you want to revert for people who are unable to present like a valid KYC to you. But most cases you don't want to revert, you just want to return um, out of the hook function. Okay. Any questions so far on everything we've talked about? Um, where was I? Okay. We were talking about not reverting the transaction, um, just returning from here. Any questions about that so far? Just post in chat. Um, but hopefully this makes sense. So we're trying to design our hook in a general purpose way where you can use this, like anybody who deploys like a meme coin or whatever can use this on their pool. So we're only checking that ETH is one of the currencies. We're not enforcing constraints on what the other currency is in the pool, right? We're not enforcing it to be like one specific meme coin only. Anybody can add this hook to their pool. We just want to make sure that ETH is one of the tokens there at least. Once we have that, we can calculate how much ETH was spent as part of this add liquidity transaction. And the way to do it is we have this delta, right? Um, and we can use the balance delta library to make our life a little bit easier over here. And we have this delta, and this delta has this function amount zero, which will give us the amount zero value, right? But then we said that amount zero is going to be negative number in the case of adding liquidity. So what we want to do is we want to flip that sign to get a positive value. And then this is an int 128 data type. So we want to bump it up, typecast it to an int 126, and then into a uint, int 256, and then a uint 256 to get this value out. And then we can simply just call our internal helper function with the ETH spend amount as the number of points we want to issue. And then finally, just return out of here with the default values. Again, we're not changing any of the default values for any reason here, right? So that is all we need for after add liquidity. After swap is similar, except we want to do one more additional sanity check in there. So with after swap, we want to make the same sanity check that it's happening in a pool where one of the tokens is ETH, the native token. Similar, then we want to do another sanity check, which is we only mint points if the swap is buying the meme token for ETH. If you're selling meme for ETH, you don't get points, right? That is not something we are trying to incentivize. So we can check that by checking if swap params 0 for 1 is false. Right, so 0 for 1 in the swap parameters means you're swapping token 0 for token 1, which is, swapping ETH for meme. But if it's false, it means you're going the other way, where you're swapping meme for ETH, in which case no points get issued, and we just want to return the default value, which for after swap is the function selector and just a 0. And if you are swapping ETH for meme, like if you're buying meme token and we're in the correct pool, then we can do a similar thing. You just calculate ETH spend amount, typecast basically delta.amount 0 over here. And then in this case, we had randomly decided that, points points for swap that you get is going to be 20% of the ETH you spend. So just divide that by 5, assign points, book data, points for swap, and then return after swap dot selector and 0. Okay. Um, Let me try force building, make sure I didn't have any typos or something somewhere. Oh, I did. Forgot to import pool key. Let me grab that real quick. And let's see. Um, okay. Hold on. Um, uh, Sorry, I'm having weird issues with Zoom today. Oh my God. So sorry. Can you guys still see my screen? Can somebody just confirm that? I think it tried to crash back out again on me.
I'm seeing a white screen.
A white screen.
Yeah.
What the hell? Um, Now? Is it better now?
No, still the same.
What the hell is happening, dude? I swear this has never happened before. Um,
Oh yeah, it's back.
it's back.
Yeah, yeah.
Do you
It's
see
good.
VS Code?
Yeah, yeah.
Okay. And then let me just make sure I can. It's going. The chat room. Okay. Cool. So yeah, I need to import pool key. This comes from core. I believe pipes slash pool key got slow. Okay. Yep. And we'll build again. Compile. Okay. Cool. So we're done with our hook at this point. Because of technical issues, we're running a little bit late in terms of time. So for the test, I'm gonna kind of, I think, I don't think we have time particularly to go over them one by one. I'm so sorry about the issues. This doesn't happen normally. I don't know what the fuck is going on today. But for the test, so we're gonna create a points.t.sol. I'm gonna copy paste this, but try to sort of go over it and review it at least and try to explain how it's working. But let me just compile and make sure everything's working. Okay. So, okay, we have a question in chat. So balance delta calculates the ratio of amount 0 and amount 1 in UniSwap before the current point. Um, it doesn't calculate the ratio. It's literally just telling you um, it's telling you like how many tokens need to be transferred at the end of the action, right? So like in the case of an after swap, it's telling you, for example, like how much ETH does the user owe Uniswap and how much meme does the Uniswap owe the user, right? In case of after add liquidity, it's telling you like how much ETH and how much meme tokens does the user need to send Uniswap. So it's just telling you like the amounts of tokens that need to be transferred for this action. Um, and that just like that is, and then like from that, we can basically extract what we're interested in, which is how much ETH the user is spending in purchasing our token or in adding liquidity. And yes, Uniswap v4 does support native tokens. So unlike v3, you don't need to use wrapped ETH. You can use actual native ETH to set up pools and stuff in Uniswap v4. There's like no longer a dependence on wrapped ETH. But okay. So for the test, what we're gonna do. is we're going to use this really nice helper library that comes with V4. It's called deployers. And what deployers does is basically this library that comes with a bunch of like helper functions for us that help us set up like a testing environment for Uniswap v4. Because if you think about like what does it mean to test a hook contract, it means like you're gonna have to locally deploy a copy of Uniswap v4, then you're gonna have to set up a pool. In that pool, you're gonna need to attach your hook contract, and then you're going to add some liquidity, and then you're going to do swaps, right? So the deployers library basically takes care of the Uniswap side of things for us, where it comes with these helper functions, which will deploy all the contracts and everything needed for Uniswap to work. And then you can just focus on writing code and writing tests for your actual hook itself. So if you take a look at the setup function, we just get this helper function, deploy fresh manager and routers. This is going to deploy like the Uniswap v4 pool manager and like router contracts for swapping and stuff that we're going to use. So this does all the Uniswap setup for us. Then we're going to create like our meme coin, mock ERC20 token, and then just mint a bunch of meme coin to ourselves. So we have something to use for adding liquidity and swapping. Um, we're going to deploy our hook contract, and we're going to deploy it to like a specific address to meet the requirements of, the address mining thing that needs to happen. So we're going to deploy our hook contract to a specific address over here. We're going to approve our meme coin for like infinite approval to the swap router and the liquidity router. And finally, we're going to create a new pool on Uniswap that is ETH versus token, our meme coin with our hook contract attached, and just uh, uh, 0.03% fees and initial starting price 1 to 1. And then we have a single test that we've written. And the single test, what we're going to do is we're going to check, okay, what is the number of points that we have initially? This should be equal to 0, of course. And then we're going to create the hook data where we just add our own address into this bytes variable. Um, and then we're gonna add some liquidity to Uniswap. By the way, this is like some of the mathematics related stuff. There's a separate blog post I have on this. We wouldn't have time to cover this anyway today, but we're gonna basically figure out how much ETH and meme token to add as liquidity. We're just gonna add some random amount of ETH and meme token as liquidity to the pool. Then we're gonna check our points balance after we have added liquidity, and we're gonna say basically that points balance after adding liquidity minus the original points balance should roughly be equal to zero point 0.1 ether, because we're adding zero point 0.1 ETH as liquidity to the pool. So we should have gotten 0.1 like 0.1 points for that as well. Then we're going to do a swap. We're going to do a pretty small swap, just 0.001 ETH to purchase meme token. We do the swap, and we fetch our points balance again after the swap, and then this should be, since we swap 0.001 ether, we should get 20% of that as points. So 0.0002 point tokens is what we should get after the swap. If I run forge test, I'll see it passes. Again, I'm sorry for all the technical issues today, but that's pretty much it. We've built our hook. I'm happy to answer any questions. I'm happy to stay a little bit over time because of the issues, but yeah, that's pretty much the hook. Super simple, nothing too complicated. And then there's something to be said around like, you know, what how can you improve this? There's a couple of problems in this hook as it exists today, that you should think about improvements. And what those are is, first of all, we're our hook contract has a single ERC20. We're not creating different point tokens for each pool. We're using a single ERC20 point token for every pool that this hook gets attached to. And, this is a little bit problematic because, if you allow for this on mainnet, somebody's just going to create a fake token, attach this hook over there, and just farm an infinite number of points for themselves because they just have infinite amount of that token for themselves. So you probably don't want to use that in prod. Instead, what you want to do is either one ERC20 per pool, or you want to use like a multi-token standard like 1155 or 6909 to sort of manage different point tokens for different pools. So that it's better like that. So you don't share the same point token across multiple pools. And the second improvement you want to do is currently there's a little bit of an issue where someone can add liquidity, remove liquidity, add liquidity, remove liquidity, and keep doing this over and over again. And they will farm a massive amount of point tokens by doing this, right? Because we're not doing anything when they remove liquidity. So if they just like add a certain amount of liquidity and immediately remove it, and then add it again and then immediately remove it again, they're just going to keep getting points for adding liquidity, but they're never going to be penalized for the fact that they're removing it instantly. So in a more sophisticated implementation, what you want to do is instead of just giving points when somebody adds liquidity, you want to have some sort of like time lock where you kind of just want to take note of the fact that this person added liquidity, and later when they remove it, you give them points proportional to how long they kept it in there, right? So you can say something like if you keep liquidity in there for like a month, that gives you like the maximum allocation of points that you can get. But if you remove liquidity after like 2 weeks, you only get half the amount of points. You only get half your allocation because you removed liquidity too fast. And if you remove it immediately, you basically get zero, right? So you can sort of curve it like that based on how long they've kept it in there. And that's like few improvements basically you can make over here. Um, yeah, that's about it on my side. And if anybody has any questions, happy to help answer. Um, yeah, and also I'm gonna uh let me drop a link to the GitHub repo for this as well. So you guys can also take a look at it later if you want to. Um, where's the recording gonna be? Um, okay, yeah. So if anybody wants to take a look at the GitHub link for this, it is available over here. And again, I'm really sorry about the technical issues today, but I don't know what's going on, dude. But yeah, any other questions from somebody before we wrap this up? I really wish we had some more time to get into the tests, line by line. I'm sorry if some of this is a bit confusing right now and how it's working out. I swear this is not normal.